What if the smartest financial institutions in the world and, the most advanced artificial intelligence labs in Silicon Valley just simultaneously realize that they've been doing everything completely wrong?
I mean, that is the big question right now.
Right. Today, we are tracking this massive pivot because usually when we look at the digital and financial systems we use every single day, there's just this baseline assumption that as things get more advanced, they naturally have to get more complicated.
Yeah, exactly.
Like we expect more layers of management, more bloated workflows, more intricate mechanisms just to get a simple task done.
It's the classic trap of technological debt.
Mm-hmm.
We build systems on top of systems, stacking new tools on top of old tools, until honestly, nobody really understands how the whole machine operates anymore. But you're entirely correct about this pivot. We are seeing a sudden, profound rejection of that philosophy across completely different industries.
And that is exactly our mission for today's deep dive. We're unpacking a really fascinating stack of sources with you today. We've got everything from a Phoenix market report on crypto data to a groundbreaking AI academic paper, a Google blog post about their newest software, and even a European regulatory report.
It's a wide net, for sure.
It is, yeah, but the goal is to show you how the world is moving away from bloated complexity. It's moving towards simple, direct, autonomous action. And by the end of this conversation, you're really going to understand why the smartest systems around us are just stripping away the complex workflows of the past.
Well, let's actually start by looking at the financial side of the equation, because the data there perfectly illustrates this broader shift in mindset that you're talking about. We're seeing a total change in how capital is being deployed.
Yeah, so we're looking at a recent Phoenix News market report, and it breaks down Bitcoin's recent surge to $83,000. Now, for you listening, the actual price here isn't the most important part of the story.
No, not at all.
It's really the mechanics of how the market drove that price up. Because historically, massive crypto rallies have been fueled by derivatives, right?
Absolutely.
People essentially taking out loans to place these highly complex engineered bets on future prices.
Right. And what's fascinating here is how we usually track that kind of speculative frenzy. We look at something called funding rates.
Right.
In a typical hype-driven crypto rally, traders just get greedy. They want to borrow money to maximize their bets. And because so many people want to borrow, the cost to do so, the funding rate just skyrockets. But the Phoenix data reveals a totally different mechanism at play during this specific run-up.
Yeah, the funding rates on centralized exchanges actually stayed negative.
Exactly.
Which means people weren't borrowing money to place bets. According to the report, there was barely any movement in the CME futures or options market at all. No significant rise in open interest, no big spike in volume or basis.
Which is wild for a rally of that size.
Right. Instead, this entire $83,000 rally was driven purely by the spot market. Spot ETFs saw massive buying pressure, and the Coinbase Premium Index actually stayed positive.
And we saw centralized exchange, cumulative volume deltas, or CVDs, just steadily increasing.
Exactly. Buyers aren't playing complex games with leverage right now. They're literally just buying the underlying asset directly.
Which tells us a lot about the maturity of the market participants right now.
Yeah.
When an ecosystem is young, you see a lot of complex, highly leveraged speculation because, people are trying to game the system for quick returns.
Right. It's a casino.
But as a market matures, institutional capital moves in, and they prefer foundational simplicity.
Okay, let's unpack this with a metaphor to really picture it. Because using massive leverage and derivatives is it's like throwing a massive wild party in a rented house.
I like that, yeah.
It's loud, it's huge, but it can crash hard and fast. Spot buying, on the other hand, is like actually buying the property, moving in, and changing the locks. It's direct action.
That's a perfect way to visualize it. And the traditional financial system is deciding to drop the wild parties and just buy the house. This direct spot buying of Bitcoin actually mirrors broader traditional market trends we're seeing.
Like the recent NASDAQ Q rally, right?
Exactly. It represents a system finding strength and stability by stripping away engineered complexity. They want the raw asset, not a complex derivative of the asset.
So dropping the complex levers to focus on direct action. And, it's easy to look at financial markets and think, well, that's just an isolated trend in finance. But the shift away from bloated toolkits is the exact breakthrough driving the absolute bleeding edge of artificial intelligence right now.
Yeah, the AI industry is experiencing a massive wake-up call right now.
Hmm.
For the last few years, the dominant philosophy was basically, if you want an AI to do more things, you have to manually build more tools for it.
Right.
We were finally realizing that throwing more and more hard-coded tools at a problem doesn't actually make models smarter. It just makes them brittle.
Yeah, and let's bring in our next source to explain this because we're looking at a groundbreaking academic paper from researchers at Princeton, Tsinghua, and a few other top institutions. They've developed a new generalist AI agent called Alita.
Alita.
Right. And the paper literally opens with a quote from Leonardo da Vinci.
I love that part.
Simplicity is the ultimate sophistication.
And they back up that philosophy brilliantly in the paper. To understand why Alita is such a big deal, we really have to look at the bottleneck in traditional AI agent systems like, OpenAI's Deep Research or Manus.
Yeah.
Those systems rely on heavy, manually predefined workflows.
So give us an example of how that bottleneck actually works in practice.
Okay, imagine you are a human software developer and you're trying to build an AI that can act as a personal assistant. If you want the AI to be able to search the web, you have to manually write the code for a specific web search tool.
Right.
If you want it to read a PDF, you code a PDF reader tool. Check the weather in Tokyo. You have to code an API integration for a weather service.
Wow.
It is fundamentally unscalable. A human developer cannot possibly anticipate and manually predefine every single tool an AI might ever need to encounter every possible real-world task.
So basically, the AI hits a problem it doesn't have a specific tool for, and it just throws an error message. It fails.
Yes, it hits a wall and just stops. Alita takes a totally different approach, which the researchers call minimal predefinition and maximal self-evolution.
Minimal predefinition, okay.
Right, instead of a massive bloated library of thousands of tools, Alita essentially just has two basic components, a manager agent and a web agent.
Wait, really? So the AI is supposed to handle complex real-world tasks with just two basic components. How does it not just get completely stuck the second it faces something complicated?
By dynamically generating its own tools on the fly using something called a code react loop.
Code react loop.
Yeah, this is the core mechanism. When Alita faces a problem, it evaluates the situation and realizes, hey, I lack the necessary tool.
Yeah.
So the manager agent dispatches the web agent to search open source repositories like GitHub for existing code libraries.
Oh, wow.
It reads the documentation, writes the Python code to build the specific tool it needs, which they call Model Context Protocols, or MCPs, creates an isolated virtual environment to test that tool, and then uses it to solve the problem.
Here's where it gets really interesting. It's like instead of putting a chef in a kitchen crammed with 1,000 hyper-specific gadgets, an avocado slicer, a strawberry huller, whatever that might not even fit the recipe.
Right.
You give them an empty counter and a 3D printer so they can instantly manufacture the exact tool they need for the dish in front of them.
That is a great analogy. And the data shows that the empty counter approach absolutely crushes the bloated toolkit approach. On the GAIA benchmark, which is widely considered one of the most rigorous multi-step tests for general-purpose AI, Alita achieved a 75.15% accuracy rate on its first try.
That's huge.
To put that in perspective, OpenAI's Deep Research scored around 67.36% on the exact same benchmark.
I want to walk through the specific case study the researchers highlighted because it perfectly illustrates this mechanism. The GAIA benchmark gave Alita this incredibly specific, honestly bizarre task.
Yeah, the VR one.
Yes. It asked, in a March 2018 360-degree VR YouTube video, which happens to be narrated by the voice actor who played Gollum in Lord of the Rings.
ID Circus. Yeah.
Right. It asked what specific number is mentioned by the narrator directly after dinosaurs are first shown.
Now, just think about the logic required there. A traditional AI fails immediately. No human developer would ever anticipate needing to pre-program a Gollum VR dinosaur YouTube transcript tool. The tool simply does not exist.
But Alita didn't fail. Step 1, its manager agent analyzed the prompt and realized it needed a way to pull YouTube subtitles. Step 2, its MCP brainstorming module sent the web agent to search GitHub.
Right.
It found an open source library called YouTube Transcript API. Step 3, it wrote the Python code, built the environment, downloaded the transcript, analyzed the text, and accurately extracted the number, which was 100,000 Madero.
It autonomously built the machinery required to solve its own problem. But what's fascinating here is that the most profound implication of Alita isn't just that it can solve a hard YouTube trivia question. It is what happens to the tools after they are created.
Oh, right, the distillation factor.
Yes, the
Yeah.
distillation factor. When Alita creates one of these MCPs, it saves it. Alita itself is powered by a massive frontier-level AI model running on supercomputers. But the tools it writes are just efficient blocks of Python code.
Okay, so what do they do with them?
The researchers took those tools and handed them down to a much smaller, lightweight AI model, specifically GPT-4o Mini, which is the kind of model that can run quickly and cheaply on everyday devices.
So going back to the analogy, you are taking the 3D printed tools made by the master chef and just handing them to a line cook?
Precisely. And the results radically changed the line cook's performance. When Alita's MCPs were given to that smaller GPT-4o Mini model, its accuracy on the hardest GAIA Level 3 questions nearly tripled.
Wow.
It went from a 3.85% success rate to 11.54%.
So instead of spending millions of dollars trying to brute force a small model to be smarter, the big model can just autonomously manufacture the perfect tool belt and hand it down.
Exactly.
Well, it's easy to look at Alita and think, okay, that's just a fascinating academic experiment. But this shift from passive tools to active self-improving agents is already entering the mainstream. Which brings us to our third source, Google's blog post, announcing Gemini 3.5 Flash.
Right.
They are explicitly billing this release as combining frontier intelligence with action.
And that word action is doing a lot of heavy lifting in their announcement. They aren't just selling a chatbot that summarizes text anymore. They are selling an agent designed to take over the wheel.
According to the release, Gemini 3.5 Flash outperforms their previous 3.1 Pro model on complex agentic benchmarks. On Terminal Bench 2.1, it scored 76.2%. But the metric that actually caught my eye was the speed.
Yeah, the 4x faster claim.
Exactly. They emphasized that 3.5 Flash is 4 times faster than other frontier models. Why is raw speed such a critical factor here?
If we connect this to the bigger picture, think about the trial and error mechanism we just talked about with Alita. Agentic workflows require the AI to think, try, fail, and try again.
The loop.
Right, the loop. If a model is slow, an autonomous loop involving 50 microactions takes forever. It becomes practically useless. But if it is 4 times faster, that rapid self-improvement loop happens in seconds. Speed unlocks autonomy.
And Google is taking this autonomous capability and plugging it directly into the real world. They are using what they call the anti-gravity harness to deploy collaborative subagents.
And the commercial examples they give are pretty staggering.
Yeah, like Shopify using subagents for global merchant forecasting.
Right, and Macquarie Bank using it to reason over 100-plus page documents for customer onboarding.
And Databricks using it to diagnose issues in massive data sets.
Notice the trend there. These aren't parlor tricks. They are actively making decisions on core business operations.
But Google isn't just targeting massive corporations. They also introduced Gemini Spark, which is this new personal AI agent that runs 24/7 on your behalf to navigate your digital life.
Right, running in the background.
And this is where I have to admit, I start to get a little nervous.
Oh, absolutely.
Because, what does this all mean for you, the listener? We are essentially giving these models the keys to the car. If my 24/7 Gemini Spark decides to take action on my emails or my finances and gets it wrong, the fallout is entirely on me. Are we moving too fast?
It is an incredibly valid fear, and it is the exact anxiety that European regulators are urgently trying to solve right now.
Which brings us to our final source today.
Yes, a publication from the European Commission Joint Research Centre, the JRC, prepared under the EU AI Act. The focus is on evaluating systemic risks in general-purpose AI models.
Okay, so how are they evaluating them?
Well, this report outlines a massive structural shift in testing. Up until now, almost all of our safety testing has been based on what regulators call capability-centric evaluation.
Meaning we were basically testing them like students taking an exam, right? Like,
Right.
Can you find the dinosaur in the YouTube video?
Exactly. Tests like the GAIA benchmark to see how smart the AI is. But the JRC report argues that because models are now taking autonomous action in the real world, testing for intelligence is no longer enough. We have to shift to evaluating general-purpose AI systemic risk, what they call GPAIR.
GPASR.
Right, because if an AI is deeply integrated into a bank's onboarding system, a failure isn't just a wrong answer on a test. It could trigger a systemic collapse.
The report says that shifting to systemic risk evaluation requires a tiered approach to safety benchmarking and strict standardization. What does a tiered approach actually look like mechanically?
Think of it like a biological quarantine protocol. Instead of giving the AI one big exam, you test its behavior in stages. Tier 1, test the agent in a completely closed sandbox. If it passes, it moves to Tier 2, where you test it on a simulated closed-loop network to see if it attempts to break out or manipulate the system. Only if it passes those tests does it move to Tier 3, where it can interact with real-world APIs in a highly monitored capacity.
And, we actually saw Google acknowledge this new reality in their release, too.
Yeah, they did.
They explicitly mentioned that Gemini 3.5 was developed under their frontier safety framework, and they specifically highlighted that they strengthened CBRN, chemical, biological, radiological, and nuclear safeguards, just to prevent catastrophic autonomous actions.
It sounds extreme, but this raises an important question. As AI moves from answering questions in a chat box to autonomously executing multi-step workflows, capability and danger become two sides of the same coin. A highly capable agent has a much wider blast radius, which is why standardized, tiered safety benchmarks are no longer optional. They are the only way to prevent systemic collapse.
Okay, but based on everything we've just discussed, isn't there a massive glaring loophole here? Well, if an AI is smart enough to dynamically write its own tools, build its own virtual environments, and fix its own code like Alita, isn't it theoretically smart enough to figure out how to pass a standardized safety benchmark while still behaving unpredictably in the wild?
Yes, that is the ultimate regulatory hurdle. Regulators are essentially trying to build a fence around a cloud. We are constantly trying to measure the safety of systems that are actively evolving their own capabilities.
That is a staggering reality to wrap your head around, but it brings us full circle to the core theme of today's deep dive. We are witnessing the evolution of action.
Truly.
Whether it's the financial markets stripping away complex leverage for direct spot buying of Bitcoin at 83K, or Alita proving that self-evolving simplicity creates the smartest AI, or Gemini 3.5 Flash deploying 247 autonomous sub-agents into our daily lives, the systems around us are taking the wheel.
The era of software waiting patiently for human input is coming to a close.
And that fundamentally shifts your role. You are no longer going to be the operator of your software. You are going to be the manager of your personal AI agents.
Which requires an entirely new level of trust.
It really does. And I want to leave you with something to chew on regarding that future. If Alita can successfully create tools and pass them down to make smaller AIs smarter, and Gemini Spark is running 2.4/7 on your phone,
Right.
how long until your personal AI agent starts bypassing you entirely to negotiate directly with your bank's AI agent? Are we ready for an economy where the primary actors are machines talking to machines?
It is the logical next step.
It really is. Thank you so much for joining us on this deep dive. Keep questioning the evolving world around you, and we will catch you next time.